Okay, that is the fourth module is of discrete time non-periodic signal, that is discrete time Fourier transform. The discrete non-periodic signals we will be preferring for DTFT only. Okay, what all the modules we are learning, it's for non-periodic signal only. Then the discrete time Fourier transform. Fourier transform representation of the non-periodic sequence x of n. It's given by x of n is equals to, observe here, 1 divided by 2 pi integration varying from 2 pi 0 to 2 pi, or else you can write as 2 pi x of e raised to j omega into e raised to j omega n into d omega, or I can write the equation as x of n is equals to 1 divided by 2 pi varying from minus pi to plus pi x of e raised to j omega e raised to j omega n d omega. This I will take as equation 1. Then where x of e raised to j omega is equal to summation n varying from minus infinity to plus infinity x of n e raised to minus j omega n, where x of e raised to j omega is known as discrete time Fourier transform, that is DTFT, of the signal x of n, and x of e raised to j omega and x of n forms a DTFT pair. In the Fourier transform, x of e raised to j omega, this omega, right? Omega x of a t, x of t, therefore this is for discrete time. The ft Fourier transform is for continuous time. X of n, it's going to following the DTFT pair, which is represented as x of n. DTFT is going to be x of e raised to j omega, or else if I come in a reverse fashion, x of e raised to j omega dt inverse DTFT if I apply, I will be getting a x of n. Here x of n, x of e raised to j omega is the frequency domain representation of the time domain signal x of n, and x of e raised to j omega is also known as spectrum of x of n. What is the need of DTFT? FT means where we can convert from frequency domain signal to the time domain signal, or else from time domain signals to the frequency domain signal. That is one main important of our DTFT or FT or DSP problems, whatever you are going to conversation if you are preferring. Okay. Then equation known. This equation 1 is known as synthesis equation, and equation 2 is known as the DTFT equation is known as the analysis equation. Now let's consider x of e raised to j omega plus 2k pi is going to be taken as changing the omega in terms of 2k pi. Okay. Therefore, what is the equation changing? Based on the equation 2. Okay, equation 2. Summation n varying from minus infinity to plus infinity x of n e raised to minus j omega plus 2k pi into n. Therefore, just a split here. What I can write, e raised to minus j omega n multiplying of these two. Okay, then multiplying with this e raised to minus j 2k pi n. Then due to the what is 2 pi, it will be 0. Then what we will be getting, this is going to be 1. Summation n is equal to minus into plus into x of n e raised to minus j omega n. Observe here, it is a periodicity. X of e raised to j omega plus 2k pi is going to be equal to x of e raised to j. What is indicating for us? This indicates that x of e raised to j omega is periodic. In terms of equation, it is periodic with a period 2 pi. Equation 2 is an infinity series, because we here only telling infinity, it's varying from minus infinity to plus infinity. This series will converge, or alternatively x of e raised to j omega will exist only if x of n is of a absolutely summable. So that what I can write, summation n varying from minus infinity to plus infinity x of n mod of iterative, it should be within the limit. That's what the condition for the stability. Same, it should affect for any of the signal if you are going to prefer, or if you are going to use in your system design. Okay, and this is only the sufficient but not necessary condition. Within the limit it is enough, but it's not necessary that it should be within the limit only. It depends on the application where we are going to use. If you are going to transformers, what you are going to use in a small device for your project phase, it is small one. A small signal, it is enough. What in terms of voltage or current, if you are what you are going to provide. But in the big industries and in KEB level or industry level, a continuous supply it should be taking place. The signal what's going for signal in terms of what you are providing as an input. The controlling operation, it should be in a continuous fashion. It's not that today it will be working and tomorrow it should not work, right? A continuously a signal it should pass, means control operation will be going, switching on off, how much the current it should flow. This all some factors affecting for your industry level, right? In that way it is taken. For that reason we here telling us not necessary but sufficient condition for the Dtft. Okay, this is about a small introduction part. Next we will go with the what are the properties we learned in the Dtft. That is, the first one is of linearity, second time shift, frequency shift, scaling, frequency differentiation, summation, convolution, modulation, Pascal's theorem, and last one is of symmetry. Almost the same properties we will be learning as we learned in the Fourier transform. Okay, next we will go with the linearity. If x of n, the Dtft is going to be x of e raised to j omega, and y of n, Dtft y of e raised to j omega, then z of n is equal to a x of n plus b y of n, Dtft is going to be z of e raised to j omega is equal to a into x of e raised to j omega plus b into x of y of e raised to j omega. What is the proof? First we have to write what is the equation for x of n, y of n in terms of Dtft. That is taken as x of e raised to j omega is equal to summation n is equal to minus infinity to plus infinity x of n e raised to minus j omega n. Then y of e raised to j omega is going to be summation n is equal to minus infinity to plus infinity y of n e raised to minus j omega n. Then what about our z of e raised to j omega is going to be, that is nothing but summation n is equal to minus infinity to plus infinity z of n e raised to minus j omega n. Now we have to substitute what is our z of n. It is considered as a into x of n plus b into y of n. That you have to substitute here, and remaining as it is you have to write. Then multiply e raised to minus j omega n for the a x of n and also for the b y of n, and take individual summation for x of n and also for the y of n. So I can write as a into summation n is equal to minus infinity to plus infinity x of n e raised to minus j omega n plus b summation n is equals to minus infinity to plus infinity y of n e raised to minus j omega n. Then what is our z of e raised to j omega is going to be, this is nothing but our x of e raised to j omega, and second term y of e raised to minus j omega n is nothing but y of e raised to j omega. That you have to write. Z of e raised to j omega is going to be a into x of e raised to j omega plus b y of e raised to j omega. This is what the proof. Then the time shift property. If x of n, the Dtft is going to be x of e raised to j omega, then y of n is going to be equal to x of n minus n naught. What is how much the shift is going to be shifted of the signal. Therefore Dtft is going to be y of e raised to j omega, that is equal to e raised to minus j omega n naught into x of e raised to j omega. Now consider the equation. X of e raised to j omega is equal to summation n is equal to minus infinity to plus infinity x of n e raised to minus j omega n. What is our y of e raised to j omega? is going to be summation n is equal to minus infinity to plus infinity y of n e raised to minus j omega n. Therefore, what is y of n? That is nothing but x of n minus n naught, that you have to substitute. Then what you have to do, just take some other variable, that is put m is equals to n minus n naught. When I substitute m is equal to n minus n naught, what is the equation is going to be modified? That is y of e raised to j omega is equal to summation m is equals to minus infinity to plus infinity. Instead of n minus n naught, I can substitute as m. Then what is the n equation? Well, from this equation, what I can write for n? N is going to be equals to m plus n naught, right? Instead of n, here it is substituted as m plus n naught. Then after substitution, after dividing the summation e power, what I can write? E power minus j omega n naught, it's a constant value, means a shift operation is going to be. For that reason, it is taken as outside, and remaining part is of summation m is equal to minus infinity plus infinity x of m e raised to minus j omega m. This is nothing but, what is that? X of e raised to j omega, and this is right as it is. This is what the proof for the time shift in terms of your Dtft. Then about a frequency shift, if x of n Dtft is going to be x of e raised to j omega, then y of n is equals to e raised to j beta n into x of n. Dtft is going to be y of e raised to j omega is equal to x of e raised to j omega minus beta. Omega minus beta. Now we will prove the frequency shift operation. Hence, consider proof is going to be x of e raised to j omega is equal to summation n is equals to minus infinity to plus infinity x of n e raised to minus j omega n. Then y of e raised to j omega is equal to summation n is equal to minus infinity to plus infinity y of n e raised to minus j omega n. Then that is going to be equal to summation n is equal to minus infinity plus infinity. What is our y of n? Here it is considered as e raised to j beta n x of n. That you have to write e raised to j beta n x of n e raised to minus j omega n. Then adding of these two in terms of exponential, then you will be getting as e raised to minus j omega minus beta into n. Therefore, what we can write? This is nothing but our basic equation only. Instead of omega, here it is of omega minus beta. Therefore, y of e raised to j omega is equal to x of e raised to j omega minus beta. Okay, that you will be getting. This is hence the proof for the frequency shift condition. Then about the scaling. The next property is of scaling. Since scaling of a discrete time signal discards information, scaling, we know that in the first module we learned, when I go for the scaling operation for the discrete time, for continuous time your signal is just scaled, it may be compressed or it may be expanded. But when we consider for the scaling operation for the discrete time signals, when it is of a fractional values in terms of time, if you are getting, that value is going to be losing itself. Loss of the signal and the sample, it's going to be occurring when I go for scaling operation for the given discrete time signal. So what it's going to be considered here? Now we'll see what it's going to be. Okay, discrete time signal discards the information. That's what the basic we learnt of that. It is not possible to express the Dtft of the scaled signal in terms of Dtft of the original signal. What is the original signal is, it's not able to reflect the same as it is when I go for the scaling operation. I hope you understood what I am going to tell. Okay, due to that we are going for some other equation way, so that I can go for the scaling operation here. But consider a non-periodic sequence, that is x of n, in such a way that x of n is equal to 0. It should be equal, when it is going to be 0, unless n by p is integer, is a integer one, and p should be greater than 1 value. Means non-periodic signals we learned. What is the formula there? 2 pi into m divided by n, capital N, right? It should be in integer format. Some of problems we solved. We are considering that condition here. Then z of n is going to be x of p n is also of a non-periodic signal. Then in this case, based on this condition, what I can write, if x of n dtft is going to be x of e raised to j omega, then z of n is equal to x of pn. Considering this condition, dtft is going to be z of e raised to j omega, that is equal to x of e raised to j omega divided by p. Now we'll prove that. That is, consider the equation x of e raised to j omega is equal to summation n is equal to minus infinity to plus infinity x of n e raised to minus j omega n. Then z of e raised to j omega is going to be summation n is equal to minus infinity to plus infinity z of n e raised to minus j omega n, that is equal to summation n is equal to minus infinity to plus infinity x of, substitute instead of z of n as x of pn, x of pn into e raised to minus j omega n. Put pn is equals to m, then z of e raised to j omega is equal to summation m is equal to minus infinity to plus infinity. Instead of pn, I can substitute as m, x of m e raised to minus j. Instead of n, what I can write, n is going to be taken as m divided by p, right? The same thing, m is taken outside here, here it is taken as omega by p only. Okay, omega by p into m. Therefore, what I can write, z of e raised to j omega is going to be x of e raised to j omega divided by p. Instead of omega, here it is of omega by p. That much scaling is going to be done for the given signal, discrete time signal. Okay. Therefore, then the next property is of frequency differentiation. If x of n dtft is going to be x of e raised to j omega, then minus jn x of n dtft is going to be d by d omega of e raised x of e raised to j omega. Then the proof is going to be x of e raised to j omega is equal to summation n is equal to minus infinity plus infinity x of n e raised to minus j omega n. Take this as equation 1 and differentiating both the sides with respect to the omega. Then d by d omega of e raised to x of e raised to j omega is going to be d by d omega of this part as it is, that is summation n varying from minus infinity to plus infinity x of n e raised to minus j omega n. Then d by d omega of x of e raised to j omega is going to be summation n is equal to varying from minus infinity to plus infinity x of n, where is the omega is varying e raised to minus j omega n. For that reason, differentiating only of that part. When I differentiate only of e raised to minus j omega n, what I can write here, we will be getting as minus jn is a constant because only omega is varying, right? Minus jn into e raised to minus j omega n you will be getting off. Again, this is taken as a one part. So d by d omega of x of e raised to j omega is equal to summation n is varying from minus into plus infinity minus jn x of n into e raised to minus j omega n. This equation, if I, when I compare with the equation 1, what is x of n? I can write as minus jn x of n, right? Comparing on this equation with the equation 1, I can write as minus jn x of n dtft is going to be d by d omega of x of e raised to j omega. Okay, we will stop here.